Hi everyone, Pete here, and welcome to this video about the rules of indices. In this video we're going to cover the content that you need to know for GCSE and IGCSE. This video will be part of a series where we discuss all of the things that you need to know about indices. We'll be talking about the rules of indices, negative and fractional indices, and how to combine all of those when the need arises. The first rule that we'll have a look at is the multiplication rule. This rule is only going to be used when we have the same base number. So for example, we might have 2 to the power of 3 multiplied by 2 to the power of 2. The multiplication rule gives us a way of simplifying this expression here. Now we could write this out as a long multiplication of a load of 2's. So for 2 to the power of 3, that would be 2 times 2 times 2. And of course 2 to the power of 2 is 2 times 2. So we can see that we have 5 2's being multiplied together, and we know that we can simplify this by writing it as 2 to the power of 5. So we can see when we're multiplying 2 to the power of 3 and 2 to the power of 2, in effect what we're doing is adding the powers together. Remember, this is only when the base number is the same. For example, if I had 3 to the power of 3 and 2 to the power of 2, I would not be able to combine those. Because we have 2 as the base number, the multiplication rule is valid. We can generalize this using a little bit of algebra. So we can say that when a number a is raised to the power of x, and we multiply that by a raised to the power of y, in effect what we're doing is adding those powers, so we would have a to the power of x plus y. So this here is the multiplication rule. The division rule, as the name explains, is when we have, similar to the case before, but instead of multiplying, we would be dividing. Of course, we might see this in two different forms. We could have 2 to the power of 4 divided by 2 to the power of 2. However, we might also see this written as a fraction because, of course, these have the same meaning. We need to be wary that both of these cases require us to use the division rule. So we can now rewrite 2 to the power of 4 as 4 of these 2's being multiplied together. And on the bottom of this fraction, we can have 2 2's multiplied together. And we know that in order to simplify fractions, we divide the top and the bottom of the fraction by the same number. In this case, I can divide the top and the bottom by 2, which would cancel out one of these 2's, and then again by another 2, so 2 and the 2 beneath. So here I would be left with 2 to the power of 2. I'll write that as 2 times 2 first, okay, which we can see is 2 to the power of 2. So what have we done with the indices? So we've actually subtracted away 2 from 4. You can see that if I had 3 2's on the bottom here, I would simply subtract another one from the initial index. So dividing is in effect subtraction of the indices. So we can write out the general case then. If a was raised to the power of x, and we divided that by a to the power of y, then the final answer would be a to the power of x minus the second index y. So this is what we call the division rule. Again, like the multiplication rule, we must have the same base when we are doing this simplification. Next, we'll take a look at what I call the power rule. So if we have 2 raised to the power of 3, and then I subsequently raise that answer again to the power of 2, let's just see what this looks like when we write it out as a long list of multiplications. So we would have 2 times 2 times 2, and well, I'd have to repeat this again because I'm squaring this answer. So it would again be 2 times 2 times 2. So if I pop brackets around these sections here, we can see what I've done a bit clearer, I think. So we've got 2 cubed multiplied by another 2 cubed. So 2 cubed, then squared. What I can now do is simplify this to 2 to the power of 6. Checking the indices, I can see that it's in effect 3 multiplied by 2 that gets me this final index 6. So the general rule in this case is that a to the power of x, which I then subsequently raise to the power of y, is equivalent to a to the power of x just multiplied by the y. So this here is the power rule. One thing about the power rule to remember is that the order in which we apply these indices doesn't actually matter. We know that when we're multiplying, xy is the same thing as yx. So if we simply switched y and x the other way round, we could have a to the power of y, then raised to the power of x. And this would be equivalent to what we initially had a to the power of x raised to the power of y. This is a little subtle trick that sometimes we might need to use when applying the power rule. So here are the three rules that we would use for simplifying expressions with indices. These rules will not be given to you in an exam, and you should certainly remember these off by heart. You will need these time and again, and I would suggest that as well as memorizing these rules, try your best to remember how we got these rules. I find that when we try and remember how we get them, it's a lot easier for students to reproduce the rule when it comes to exam questions. So building from these rules, there are some cases that we want to have a look at in a bit more detail that I find that my students often get confused by. We have a fraction that is being raised to a power. We're looking at this example because sometimes students think that we're just taking the 4 and timesing it into the bracket, or we're just doing the top. We could write this expression as a over b times by a over b times by a over b, and a final a over b there at the end. So if we look along the top of all of those 4 fractions, we would have 4 a's, and at the base we have 4 b's multiplied together. So in effect what we've done is just bring in this top power and place it as the power of our a and b. This second example is a situation where many of my students make the same mistake, where they try and bring in the 4 as the power of a and the 4 as the power of b. So we would have a to the power of 4 plus b to the power of 4. This is definitely very incorrect, and it's lost my students many marks over the years. This expression is not the same thing as a times by b to the power of 4, in which case we would raise a to the power of 4 and b to the power of 4 because there is multiplication inside the bracket. When it's addition or subtraction inside the bracket, we are not allowed to do that. So we would not be able to just bring in the power to the tops like this. We would instead need to write out the brackets and expand. And there is another video on the channel that talks about expanding and factorization if you're not sure about that and you want to check that topic out. Finally, there are some important powers that we should remember the meaning of. So first we're going to have a look at to the power of 0. Now this situation always results in an answer of 1. There's a quick and easy way to show why this must be the case. So let's start off with a to the power of 1, a to the power of 2, a to the power of 3. Now we can see that written out this would be 3 a's multiplied together, and written out this would be 2 a's multiplied together, and of course this is just a by itself. So subtracting 1 from the power on the left is equivalent to dividing by a on the right. So if we take this pattern one step further and we subtract 1 on the left, that would be a to the power of 0. And if we divide it by a again on the right, a divided by a, of course, is 1. And because we've used an unknown variable here, this means the rule is true for any number. So any number raised to the power of 0 is always going to be equal to 1. Of course, I shouldn't really have to add this, but just for completion, anything to the power of 1, of course, is just that number itself. Anything to the power of 1 is just one of those numbers. So here are all 5 of the things that we should remember from the basic rules of indices. We have the multiplication rule, the division rule, and the power rule, and these 2 special values of the index 0 and 1 that we should also understand the meaning of. So we're going to have a look at some examples now where we utilize all 5 of these in order to simplify some expressions. Let's have a look at these 3 questions here then. So the first question, I can see that the base numbers are the same. Remember, this is something to always check. And then I can see that the powers are 6 and 6. So using the multiplication rule, I know that I need to sum together those indices. So it would be 6 to the power of 6 plus 6 which I can write as 6 to the power of 12. Now, I could work these out into a long number, but 6 to the power of 12 is a pretty big number, so I'm just going to leave it like that. For the second example, I'm first going to do this bracket raised to a power. Okay, so we should remember that this is the power rule. So 4 to the power of 4 to the power of 4 means that I would multiply those two powers together. So I would get 4 to the power 4 times 4, which is 4 to the power of 16. Now in this case, it might not be obvious what to do next. However, we must remember that any number by itself is that number to the power of 1. Now once I've done this, I see that it's again a multiplication rule that I must use. So it's 4 to the power of 1 plus 16, which is 4 to the power of 17. Now for the final question, I have three things multiplied together, so this is just the multiplication rule again. So I've got 5 and 3 and 4, so I'm just going to sum together those three indices, and it's going to be a to the power of 12. Let's take a look at two examples that are slightly harder than the previous ones that we looked at. So on the left-hand side here, I have a division of these two brackets. Now I would suggest whenever you get a question like this, and just transform it into a fraction first. So what I'm going to do is write it out as 16 c to the power of 9 divided by 4 c to the power of 5. Now in this case, we should know that there is a multiplication symbol between the 16 and the c and the 4 and the c. So we can separate this out into two different sections. The first is dealing with the numbers, or what I call the coefficients, of our unknown variable c. So I'm just going to deal with the 16 and the 4 in this fraction first. Now 16 and 4 we can divide both by 4, so I would have a remaining 4 there, and the remaining 1 there after a division by 4, top and bottom. Now on the right hand side with the c's, this is a division of c to the power of 9 by c to the power of 5. So I'm going to use the division rule, which just is a subtraction of the two indices. So 9 minus 5 is going to leave me with c to the power of 4. So the final answer then, with the 4 remaining on top from just the numbers, and c to the power of 4 from using the division rule to subtract away the indices. Let's move on to the second question then. There's going to be a hidden multiplication sign here between the 3x and the bracket, and we know using BIDMAS or BODMAS that we're going to need to do the bracket first, then the index. So there's nothing we can simplify inside the bracket, so we move to look at the index. We can see that that is the bracket to the power of 3. Now here, because there's multiplication happening inside the bracket, I can take down this power and raise everything inside the bracket to the power of 3. So what that's going to look like is 3x, and inside the bracket I would have 2 to the power of 3 and x to the power of 2 times 3, which is 6. So now I can expand this bracket out. It's actually just a simple multiplication all the way through, so we can just remove the brackets. So we have 2 to the power of 3 times by 3. 2 to the power of 3 is 8, times by 3 is 24. And we have x to the power of 1 times by x to the power of 6. 1 plus 6, using the multiplication rule, is x to the power of 7. Let's have a look at one final question. This question here is about as hard as a question might be without using negative or fractional indices. So in order to simplify this, we first need to spot that this fraction on the left-hand side can be simplified. We look at the 12 and the 6, remember we look at the coefficients first, we see that both can be divided by 6. Here would leave me with a 2, here would leave me with a 1. Now we look at the x's, and we see that it's x to the power of 10 divided by x to the power of 6. Division, so we're going to use the division rule. We know that this is a subtraction of the indices, so 10 minus 6 is going to leave us with to the power of 4. So this would be 2x to the power of 4. And then we just bring down this 7x to the power of 4 that we have from the question. In this case, we can spot that we have like terms. So we have something x to the power of 4 plus something x to the power of 4. Remember that we call these like terms in algebra, and we can simplify them by summing them together. So here, I would just ask myself, how many x to the powers of 4 do I have in total? And it is 2 plus 7, which is 9x to the power of 4. And so that is the simplified form for that question. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comments section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.